Have you ever tried to move a heavy piece of furniture? It's a common struggle many of us face. Maybe you needed to rearrange your room to create a new look or make space for something new. You push and pull with all your might, but it just won't budge. It's like the couch is glued to the floor, refusing to move an inch. What makes it so hard to move? Why does it feel like an impossible task? The answer, my friends, lies in the concept of force. Force is what makes things move, or keeps them from moving. It's essentially a push or a pull that acts upon an object. When you try to move that couch, you're applying force to it. But the couch isn't just sitting there passively. It's pushing back. It's pushing back on you with an equal and opposite force, making it feel incredibly heavy. That's why it feels so heavy and difficult to move. But don't worry, understanding forces isn't as hard as moving that stubborn couch. Once you grasp how forces work, you'll start to notice them in everyday life. It's like having a secret code to unlock the mysteries of the universe, making the world around you even more fascinating. Forces are all around us, even if we can't see them. They are the invisible movers and shakers of our world, constantly at play. They're like invisible superheroes, always at work, making things happen without us even noticing. Forces can be contact forces, like when you high-five your best friend or kick a soccer ball. These are the forces we can feel directly. These forces happen when objects touch each other, creating a direct interaction. Then there are non-contact forces, which are equally fascinating. These forces are super cool because they can act on objects from a distance. Think about magnets and how they work. Have you ever seen two magnets pull towards each other without even touching? It's like magic. That's the magic of non-contact forces. They can influence objects without any physical contact. Gravity is another great example of a non-contact force. It's what keeps us from floating off into space. Gravity pulls us towards the Earth, keeping us grounded. Now let's dive into the fascinating rules that govern forces in our universe. Sir Isaac Newton, a brilliant scientist from the 17th century, formulated 3 fundamental laws of motion that explain how forces interact with objects. Don't worry, these laws are much easier to grasp than they might initially seem. Newton's first law of motion, often called the law of inertia, states that an object at rest will remain at rest, and an object in motion will continue moving at the same speed and in the same direction unless acted upon by an external force. This principle is known as inertia, which is the resistance of any physical object to a change in its state of motion or rest. Imagine you're riding your bike and you suddenly stop pedaling. What happens next? You'll keep moving forward due to inertia until a force, like friction from the brakes or the ground, causes you to stop. Newton's second law of motion provides a quantitative description of the changes that a force can produce on the motion of a body. It states that the force acting on an object is equal to its mass times its acceleration, or F equals sine ma. In simpler terms, the heavier an object is, the more force you need to apply to make it move or accelerate. Think about pushing a shopping cart in a grocery store. An empty cart is much easier to push than a full one loaded with groceries, right? That's because the full cart has more mass, requiring more force to move. Finally, Newton's third law of motion states that for every action, there is an equal and opposite reaction. This means that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force back on the first object. Remember that couch we talked about earlier? When you push on the couch, it pushes back on you with the same amount of force, even though it might not seem like it. This is Newton's third law in action. Understanding forces isn't just about passing science class, it's about understanding how the world works. Engineers use their knowledge of forces to design buildings, bridges, and even roller coasters. Doctors and nurses use forces when they give you a shot or take your temperature. Even chefs use forces when they mix ingredients or knead dough. Forces are everywhere and they make our lives possible. So the next time you see something move, or even stay still, take a moment to think about the forces at play. You might be surprised by what you discover.